Hello and welcome. Today we'll be looking at a statistics question which is from my mechanics statistics paper T. As I mentioned in the past, I've done this binomial question and I think I'm going to do a question on tree diagrams, which is somewhere here. And it's actually reversing a tree diagram. It's not obvious what we are trying to do here. This is what the question is saying. So I'm going to go through the question very, very quickly. And just show you a few of the techniques involved. The probability of Phil goes to work by car, by bicycle or on foot is such and such and such. Okay, so let's say C for car, B for bike, pardon me, F for foot. I do apologize, this video is not going to be that great. I feel really rough today. So that's a half, 1/6, and 1/3. And the respective probabilities of Phil being late when using these forms of transport. So that's the late ones. So, oops. And we're going to put the non-lates as crossed out like this. But the lates is 1/5 here. Therefore, 4/5 are not being late. 1/10 being late when he's on the bike, 9/10, and then similarly 1/20 being on foot and being late, and 19/20 not being late and having trouble by foot. But this is not what the problem is all about. I don't know if you can see on the actual paper, they want us to reverse this tree diagram rather. They want us to have to look like late, not late, and then of course car, bicycle, foot, car, bicycle, foot, and of course we need to put the probabilities, the correct probabilities, and it's not as straightforward as it looks. I have done a similar question before, and I've done it a completely different way because this tree diagram was a 2x2, so it was 2 and it was going into 2. So I'll just use a slightly different technique just to illustrate variety more than anything. But the question now is how on earth we're going to deal with a problem like that. Okay, is for example, the car a half? No, the answer, when you're looking at car here, the product of that times that plus the product of that times that should give you this half. So it should be the answers at the very end. So it's going to be a lot of complicated equations perhaps when dealing with a problem like that. So I'm going to show you a way of dealing with this particular problem. I'm going to wrap that off and show you how a problem like that, how easy it is to actually deal with it once you have really thought about it. Okay, I'm looking at all the probabilities that have been given, irrelevant what they are: half, 6th, 3rd, 5th, 10, and 20th. Okay, the thing that comes to my head when I look at all these numbers, going back to my primary, is in fact lowest common multiple. So I'm going to make a hypothetical number and say, you know what, I'm going to have 120 pieces of data, 120 days where I use a variety of transport and I have a variety of outcomes in terms of being late and not late. So what I'm going to do here is I'm going to put something like late, not late, and the things are car, bike, and foot. And I'm going to do a two-way table. Total, and you'll see very, very soon how simple this is. Okay, so let me move the paper out of the way. So there's my two-way table. And let's use a different color pen. Let's say we have 120. You can see where the 120 came from. Is to make my calculations very, very easy. Now, the probability that Phil goes to work by car is a half. So that means the total times out of the 120 should be 60 times he traveled by car. 1/6 he went by bicycle. So 1/6 of 120 is 20, and it should be 60, 80, 40. And of course, that should be a third of 120, so that works fine. So I'll just use basically these three facts by filling in the totals at the bottom of this two-way table. Where do I go next now? The respective probability of Phil being late when using these three forms of transport is 1/5. So what's this 1/5? This 1/5 is being late when going by car. So he's gone by car 60 times, and a fifth of the time he's turned out to be late. So 12, 1/5 of 60, is going to be late by car. Therefore, 48 is the rest to make the total. 1/10 of the times he traveled by bicycle, he's going to be late. 1/10. So that's 2. And therefore 18 here. And by foot, or rather on foot, is 1/20th. 1/20th of 40 is also 2. And therefore this will be 38. And we can do the adding, 14, 16. 40, 50, 80, 80 plus 24 is 104, which it does agree. So all I've done so far is I've just put this bit of information into a two-way table. And now I can actually extract it. I hope I can actually fit it in there. It does fit to actually see the tree diagram. So as the question dictates to do it, so we have the late, not late, and then we have 1, 2, 3, 1, 2, 3, and we got C, B, F, C, B, and F. And now look at this two-way table. The game is up. The probability of being late is, of course, I'm going to leave them out of 120 to make it nice and easy. So I'm looking at 16 out of 120. Just looking at this number. And therefore, not late is, of course, the rest. 104 out of 120. Now, given I'm late, so I'm looking at the late ones now, which is out of 16. So all of this will be out of 16. Okay, the probability of being late via a car is 12/16. The probability from a bike is 2, and it's also the same big on foot. So this, of course, gives us the correct information for these branches. And from the non-late, all of this now we're going to be out of 104. Oops, out of 104, out of 104. And the probability of being late by using a car is 48 out of 104. By using a bike is going to be 18 out of 104. And lastly, 38 out of 104. And as just a little check, okay, you can actually just multiply branches and just see if the original probabilities that we have marked in there do kind of tally with what we've just done in there. Okay, this and many other questions you will find in my website, madasmaths.com, and a lot of these questions will find their way into my practice papers. So this particular paper is on the mechanics, sorry, not this particular question rather, is on the mechanics statistics paper T, and I hope you followed it. It's actually very simple once you see how it's done. I'm going to be signing out. I'll see you real soon. Bye for now.